be made of checklists associated with the permit to work. Although there may be a good awareness of safety matters among the crew, checklists, when followed, are the best way of ensuring that no items relevant to the operation have been missed. Likewise, the information available elsewhere in the Safety Management System manuals, industry regulations and guidelines, and manufacturers' handbooks should be consulted as required. Experience, too, should be considered a good source of information, whether from those on board or by communication with shore. Asking for an additional opinion should be viewed as a positive and practical approach, and open communication should be encouraged. The responsible person is charged with ensuring the plan is implemented and followed. He also has to monitor the actual circumstances and determine whether they match those predicted at the planning stage. If necessary, he should make minor adjustments to the plan, always making sure that those involved are aware of the changes. All individuals involved in the operation must perform their allotted duties as outlined in the plan, reporting to the responsible person as required. When the vessel is in a repair yard, the yard safety department will also implement their own safety procedures, including control of the enclosed space entry, which may be quite extensive and may or may not involve members of the ship's crew. A chemist will normally board the vessel at the beginning of the working day and test and approve all enclosed spaces planned for entry, and will return as further testing is required. A responsible person, designated by the master, should liaise closely with the shipyard safety manager, and should also accompany the chemist when he tests the spaces. Copies of the shipyard gas-free certificates should be given to the ship, and it is normal practice to post a current copy at the head of the gangway. The responsible person should also advise the safety manager and chemist of any enclosed space entry operations that are planned solely for ship's staff. It is standard practice that shore personnel usually want to start working a ship as soon as it comes alongside. This situation has been somewhat controlled since the introduction of security practices in recent years. The vessel in this incident had loaded a cargo of round wood logs in West Africa and arrived to discharge them in a port in southern Spain. The holds had remained shut due to poor weather in the Atlantic, and no ventilation had been carried out. As soon as she was alongside, the crew of shoreside stevedores were on board to commence work. The ship's deck crew began opening the hatch to hold number 2, and a number of stevedores were seen to enter down the access ladder at the after end of the hold. On reaching the top layer of the cargo, one man was seen to slip and fall into a gap between 2 large logs. Seeing him drop, 3 of his colleagues rushed to the spot and attempted to rescue him. They too collapsed, one of them also slipping down into the gap. The second officer, who was watching from the deck above, raised the alarm, and the port safety officials and local fire brigades soon arrived. The problem of rescue was compounded by the added risk of movement of the cargo, if any one log was moved to gain access to the casualties underneath. 2 men were recovered relatively quickly, but surrounding logs had to be secured in place and several pieces of timber lifted carefully clear to get to the others. One man had fallen down between the logs to a depth of around 3.5 meters. It took almost an hour to bring all 4 men out of the hold, and all were declared dead on arrival at hospital. Logs where the bark has been stripped off are known to be dangerously slippery. Freshly cut logs are also known to deplete oxygen in enclosed spaces, and the hold had not been ventilated. These 2 factors contributed to the deaths of the 4 men. Space should be adequate, clean and clear. Personnel should be briefed on any specific access hazard identified in the risk assessment, and due precautions, such as extra safety lines and additional reporting at specific points, should be implemented. If additional illumination has been identified as required, then this should be prepared. This may include removing additional manhole covers and lids, installing temporary lighting, and/or issuing portable flashlights. Flashlights should be provided as emergency backup in the event of failure of temporary electrical or air lighting, or for use in dark corners that are shielded by framing. Wherever possible, portable flashlights should be able to be clipped to a harness or belt in order to keep both hands free. If applicable, they should be of an intrinsically safe design. No source of ignition should be taken or put into the space unless the master or responsible person is satisfied that it is safe to do so. This will most commonly be a part of a hot work task, and all additional precautions with that operation should be taken. It is essential that exposure to any dangerous products is minimized or even eliminated altogether by seeking alternative solutions. In any event, the products must be thoroughly researched as part of the risk assessment, including reference to the applicable material safety data sheets. If applicable, personnel should use the appropriate personal protective clothing and equipment. Click on the equipment for more information. In all cases, rescue and resuscitation equipment should be positioned ready for use at the entrance to the space. Rescue equipment means breathing apparatus together with fully charged spare cylinders of air, lifelines and rescue harnesses, and flashlights or lamps approved for use in a flammable atmosphere, if appropriate. A means of hoisting an incapacitated person from the enclosed space may be required. Rescue harnesses should be worn, and, unless impractical, lifelines should be used. The use of harnesses and lifelines is dictated by the procedures outlined in the company safety management system and the nature of the particular operation. They are not universally popular and can sometimes be restricting and cumbersome, but without doubt, if a casualty is already wearing a harness, then precious seconds are saved in the event of an emergency. The number of personnel entering should be limited to those who need to work in the space. In other words, those not needing to actually go inside the space should remain outside and not be unnecessarily exposed to the hazards of an enclosed space. The enclosed space entry procedures, as outlined in the safety management system, should be implemented. Those personnel entering the space must register with the attendant, who tallies them into the space. This will normally involve handing over a personal tag or signing a tally board. In this way, it is clearly known how many persons have entered the space and their identity, information that is critical in the event of an emergency. Under some systems, the attendant may also be required to report this information to the officer on watch or the responsible person. At least one attendant, sometimes called a watchman, should be detailed to remain at the entrance to the space while it is occupied. This person must be assigned solely to this task and fully briefed as to their duties and responsibilities, including monitoring the activity inside, reporting, and especially the action they must take in the event of an emergency. The attendant must not leave or pass the duty to someone else unless instructed to do so by the responsible person. A system and format of communication should be established and agreed upon between any person entering the space and the attendant. In particular, emergency signals must be clearly understood. The attendant must also be able to communicate at any time with the responsible person and the officer on watch. A backup system of communication, such as tugging on a lifeline, flashing a light, or hand signals, should also be agreed upon prior to entry. The risk assessment should have identified whether entry into and through an enclosed space with breathing apparatus is possible. Any difficulty of movement within any part of the space, or any problems if any incapacitated person has to be removed from the space as a result of breathing apparatus or lifelines or rescue equipment being used, should be considered and any risks minimized. Lifelines should be long enough for the purpose and capable of being firmly attached to the harness, but the wearer should be able to detach them easily should they become tangled. The Sapphire was a chemical tanker of 14,002 deadweight tons, built in 1997. She had loaded 16 parcels of chemical products at US Gulf ports, 2 being discharged at 2 ports in Turkey, and the remainder for discharge in Haifa, Israel. The ship sailed from Ambali in Turkey on the afternoon of the 23rd of April 1999, bound for Haifa. After clearing the port, it was planned to clean No. 2 center tank, which had contained linear alkyl benzene, and No. 6 center tank that had contained HMD, hexamethylene diamine solid. No. 6 center had been purged with nitrogen prior to loading in the US Gulf. Although now diluted, the tank still contained a mixture of nitrogen and air, and a nitrogen tag was attached to the lid. The cleaning plan was discussed between the master, chief officer and the pumpman, and involved machine washing both tanks for 45 minutes with salt water, followed by a 20-minute freshwater rinse, then leaving them venting overnight prior to mopping the next morning. The washing was carried out by the pumpman and 3 crew members from 16:45 hours until dinner at 1800 hours. Over the meal, the pumpman dismissed the sailors who had been assisting with the operation and then returned to the deck with the crew boy to rig the ventilation equipment. At approximately 1950 hours, the chief officer was doing his deck rounds and noticed that the lid on No. 6 center tank was fully open. This was unusual, as the lid was normally just cracked during venting to keep a slight overpressure in the tank. Looking inside, he saw the deck boy lying on the first platform of the access ladder, approximately 4 meters down into the tank. He was wearing a filter mask, was lying partly on his back and slumped against the rails. The pumpman was further inside the tank and slumped over the top safety hoop on the next ladder down, with only his feet being trapped under the platform, stopping him falling to the tank bottom. He immediately ran aft trying to raise the attention of the bridge personnel by waving his torch. The officers' and crew's recreation rooms were just inside the accommodation door, and the chief officer summoned all personnel present, returning to deck without actually setting off any general alarm signal. Breathing apparatus and other equipment was quickly gathered and brought to the hatch of number 6 center tank. The chief officer was the first person to enter the tank, but only wearing an emergency escape breathing device that he had collected from the manifold safety store. He tried to lift the deck buoy, but this was not possible, though he did check for a pulse. He could not detect anything. At this time, the third engineer, who had taken a self-contained breathing apparatus from the CO2 room station aft, entered the tank to assist. Unfortunately, the chief officer's low-pressure alarm now went off, and he had to exit the tank. The third engineer momentarily came out to collect a safety harness and rope to attach to the deck buoy, and the second engineer, who was also by now equipped in an SCBA, entered the tank with him. The restricted location of the casualties was proving a problem for the would-be rescuers, and it was obvious that there was not enough room for them all. So the second engineer left to assist from outside. The third engineer attached the harness and the rope around the deck buoy, and he was lifted out by the crew on deck. The rope was then transferred to the pumpman, and he was also pulled to the deck, with one man guiding the body from below. Attempts were made to revive both of the casualties, but without success. The experience of the pumpman, the presence of a nitrogen tag on the lid, and the rigging of the ventilation equipment all point to the pumpman understanding that the atmosphere inside the tank was hazardous. The deck boy had only been on board for a month, and it is reasonable to assume that he simply followed the more senior man. Closed space has been permitted because the responsible person has verified that the preparations, as established in the plan, are all in place. Note that, unless all necessary safety precautions can be followed, an enclosed space should only be entered by personnel wearing breathing apparatus, appropriate personal protection against exposure to flammable, toxic or corrosive cargo vapours, and, if practicable, a lifeline. The operation has now entered the next phase, and many of the precautions will continue to be required. The continuing safe occupation of the enclosed space depends on those who have entered the space and the attendant remaining alert and watching for any changes in circumstances that may render the space unsafe. Positive fresh air ventilation should continue during the period that the space is occupied and during temporary breaks. In the event of a failure of the ventilation system, any personnel in the space should leave immediately. The atmosphere should be tested periodically whilst the space is occupied, both for oxygen content and the presence of flammable vapours. Personnel should be instructed to leave the space if any deterioration of the conditions is noted. The atmosphere should be checked periodically from a remote location, normally the deck, and the readings recorded. The team inside should also have their personal monitors, programmed to read the atmosphere continuously. Preset alarm levels should trigger both an audible and a visual alarm on the unit in the event of deterioration of the atmosphere in the vicinity, or in the event of a failure of the monitor. Some units also have a vibration capability. If unforeseen difficulties or hazards develop, the work in the space should be stopped and the space evacuated so that the safety of the situation can be reassessed. Permits should be withdrawn and only reissued with any appropriate revisions after the situation has been reassessed and any additional controls deemed necessary have been put in place. If the period of validity of the enclosed space entry permit or other relevant permit to work has expired and not been replaced or renewed, then work should cease, and the space should be evacuated. This is a situation that should not occur with a well-planned operation and close monitoring of the situation, but it must be appreciated that such permits do expire, and, if exceptional circumstances have led to the permit reaching the limits of its validity, then exiting the space is the only option possible. If any personnel in a space begin to feel sick or dizzy, or are in any other way adversely affected, they should give the prearranged signal to the attendant standing by the entrance and immediately leave the space. If the attendant is concerned by the signals or actions of the team inside, they should immediately raise the alarm. If someone inside the space is feeling unwell, they may have difficulty in exiting the space and be in need of assistance. Should an emergency occur, the general alarm should be sounded so that the rescue team immediately assembles and backup is available. The attendant should remain by the access to the space and clearly and calmly inform the emergency team leader of the situation when they arrive on site. Depending on the assigned safety duties on the vessel, the attendant may be in the part of the rescue team to enter and undertake the rescue, but they should not, under any circumstances, enter the space alone or before the rest of the rescue team has arrived. The rescue team must be well prepared and trained regularly, because time is critical in recovering casualties who have been overcome in enclosed spaces. Crew members with enclosed space entry or rescue responsibilities must take part in an enclosed space entry and rescue drill on board the ship at least once every 2 months. They should be thoroughly familiar with the rescue equipment and effective in working and communicating as a team. If air is being supplied through an airline to the person who is feeling unwell, a check should immediately be made that the air supplied is being maintained at the correct pressure and is free from sources of contamination. The cause may be related to heat exhaustion, but if the problem originates with the air supply, others being supplied from the same source may also become affected. Once the casualty is reached, the checking of the air supply must be the first priority. Unless they are badly injured, such as having sustained a broken back, they should be removed from the dangerous space as quickly as possible. If movement is not immediately possible, then resuscitation and medical equipment will need to be taken inside the space. The medical team may have to wear breathing apparatus themselves to treat the casualty. This ship was a 9,695 deadweight tons chemical tanker. At the time of the incident, she was engaged in tank cleaning following discharge of a cargo of ethylene dichloride. The center tanks were stainless steel, and the wing tanks had a zinc silicate coating. The pumpman and a sailor were running the machine cleaning, and the boatswain was following behind with another sailor, starting ventilation fans as the washing finished, and then ejecting the remaining washing water from the after ends of the tanks. The first 2 tanks were tested by the chief officer, but he then went to attend to planning for the next cargo, leaving the subsequent testing in the hands of the boatswain, who had received training in the use of testing equipment and was approved as an operator under the vessel's safety management system. Tank number 4 center port was tested, and 21% oxygen was found. No evidence of toxic gas was noted. A green safe for entry tag was fitted to the lid, and the appropriate entry permit was filled out, although it was added to a folder of permits without the chief officer's verification signature being obtained at that time. The boatswain entered the tank, climbing down the access ladder while the sailor lowered the suction hose from the ejector pump through a cleaning hatch above the sump. He did not wear any breathing apparatus or carry an emergency escape breathing device with him. At the time, the sea was calm, and the vessel had a considerable stern trim and a slight list, so quite a lot of water was lying in the outboard after corner of the tank. The boatswain commenced removing this water, holding the suction pipe at a slight angle to maintain the suction. After approximately 2 minutes, and with around half of the water removed, he got a sudden blast of cargo vapour full in the face. He immediately dropped the ejector hose and ran towards the ladder. Catching his breath, and with eyes watering, he climbed out of the tank, more by feeling his way from rung to rung than anything else. The sailor on deck had seen the boatswain running away, and already raised the alarm through his radio to the bridge. The chief officer had also heard the broadcast, and was already halfway up the deck, as the boatswain emerged through the hatch. The boatswain vomited over the side, and then sat down, gradually recovering over the next 15 minutes or so. The chief officer tested the atmosphere in the tank for the record, but the ventilation fan had already stirred up the vapour to a noticeable level anyway. It was found that the cargo residue, being of a greater density, had settled beneath a layer of water in the corner of the tank. As the water was removed by the ejector, the product was exposed and the vapours were released. The meter readings obtained before entry were correct, because the cargo residue was effectively contained by the water, and the air above had been successfully purified by the ventilation fan. The boatswain was not aware of the risk of cargo remaining, and simply trusted the meter readings. He did react when the conditions changed, but was lucky to escape from the tank without serious injury. Once the task inside the enclosed space is finished, the following items must be completed. Click on the tasks for more information. This incident involves a chemical tanker which had stainless steel center tanks, with coated wing tanks on either side. Her crew was comprised of men of several nationalities. The ship was in ballast and had just finished cleaning tanks. They were in the final stages of mopping and drying in preparation for the next cargo. The chief officer, who had been on deck throughout, was closely supervising the operation, although the details of the enclosed space entry permits are not available. The tanks had, however, already been gas-freed the previous day, and the deck crew had been inside for ejecting and mopping. The chief officer had also been inside all of them for inspection. On the day of the incident, the deck crew was divided into 2 teams of 2 seamen each, in order to speed up the final preparations. It eventually became a practice that they went in and out of the tanks with minimal supervision by the chief officer or attendants from the deck. The afternoon coffee break came, and the deck was suddenly deserted. The officer on watch on the bridge saw dark clouds approaching, and it soon started to rain heavily. The watchman was sent to inform the crew of the rain. 2 men were sent on deck to close the tank lids. Many of the tanks were almost in load-ready condition, and it was important that they did not get rainwater inside. The 2 men hurried from lid to lid, swinging them over and throwing the securing dogs on, with a few quick turns to each. The rain eventually passed, and the pumpman went out to once again check the tanks. He was halfway through tightening the dogs on number 5 centre tank lid when he heard a faint knocking coming from inside the tank. He immediately opened the lid back up and found the chief officer clinging onto the ladder, breathing heavily. He had one safety shoe in his hand and was weakly banging at the inside of the tank hatch. Luckily, he was only suffering from shock and fatigue. Failure to observe basic enclosed space entry procedures and the independent actions of the chief officer primarily led to this near-miss incident. Is suspect or unsafe to enter, then the space should only be entered if it is essential for testing purposes. That is, testing cannot be properly or adequately carried out from a remote location, for the safety of life or of the ship, or for essential operation. Under such conditions, breathing apparatus should always be worn. The number of persons entering the space should be the minimum compatible with the work to be performed and necessary for any additional safety precautions to be applied. Persons entering the space should be provided with calibrated and tested multi-gas detectors that monitor the levels of oxygen, carbon monoxide, and other gases as appropriate. Rescue harnesses should be worn and, unless impractical, lifelines should be used. Protective clothing should be worn if there is any risk of toxic substances or chemicals coming into contact with the skin or eyes. An unsafe or suspect atmosphere is a higher risk operation, and the responsible person should maintain a higher level of monitoring and control. We have already established that there are two basic types of breathing apparatus in use at sea: the self-contained compressed air type and the externally supplied airline type, which may be connected to a compressor or to a bank of compressed air cylinders. There are particular procedures and precautions associated with each type. Click on the labels for more information. Where remote testing of the space is not reasonably practicable, or where a brief inspection only is required, a single airline supply may be acceptable, provided the wearer of the breathing apparatus is so situated that he can be hauled out immediately in the case of an emergency. However, for preference and if available, a self-contained breathing apparatus should be worn in such circumstances. In addition to rescue harnesses, wherever practicable, lifelines should be used. Lifelines should be attended by a person stationed at the entrance who has been trained in how to pull an unconscious person from an enclosed space. If hoisting equipment would be required for any such rescue, arrangements should be made to ensure that personnel would be available to operate it as soon as necessary. Where appropriate, portable lights and other similar equipment should be of a type approved for use in a flammable atmosphere. Should there be any hazard due to chemicals, whether in liquid, gaseous or vapor form, coming into contact with the skin and/or eyes, then protective clothing must be worn. The gas carrier, Happy Falcon, of 3,366 gross registered tons, arrived alongside in Zeebrugge, Belgium, early on the 10th of January 2003, and commenced preparations for inerting and gas-freeing operations. The nitrogen was being supplied by a shoreside contractor. The ship was to load a full cargo of propylene in her 2 tanks. Number 1 tank had previously been loaded with Raffinate 1 and required inerting with nitrogen to below the lower explosive limit, and then gas-freeing. The tank was then to be inspected and, if accepted by the surveyor, purged again with nitrogen prior to loading. Number 2 tank had previously contained propylene and did not require inspection or purging. At 01:45 hours, prior to inerting number 1 tank, readings of the atmosphere in the tank were taken, and gas concentrations of 5.7% at the top, 5.2% in the middle, and 3.7% at the bottom were observed. Hoses were connected at 02:05 hours, and the tank was depressurized to shore. This was completed at 03:35 hours, and nitrogen was started into the tank at 03:40 hours. Nitrogen was being supplied into the top of the tank, with the gas vapour being expelled out through the liquid line in the bottom of the tank and to a flare on shore. Readings were taken at intervals, showing a progressive drop in the gas concentration. At 08:30 hours, nitrogen was stopped and the tank dome lid was opened in preparation for inserting the shore ventilation hose. The chief officer, third officer, and an AB were attending to this task, the AB on the jetty, the third officer pulling the hose towards the tank lid, and the chief officer guiding it into position at the lid. The third officer was facing out towards the ship's side rail as he was working, and was not aware of the activity actually taking place at the tank lid. He heard a noise and turned around, but could not see the chief officer. He moved towards the dome and looked down into the tank, where he saw the chief officer lying on the middle platform of the ladder, halfway down into the tank. The third officer ran into the accommodation, raised the alarm, shouted to the personnel present in the mess room, telephoned the bridge, and made a broadcast on the PA system before returning to the deck. It was 08:51 hours. The AB returned on board and prepared to enter the tank with a safety line. The shore supervisor also climbed on board and warned the AB not to enter without breathing apparatus. Personnel and equipment were arriving on site, however, and the AB donned a self-contained breathing apparatus and entered the tank. The shore supervisor raised the alarm on shore and called the emergency services. At approximately 08:55 hours, the chief officer, supported by the AB from underneath, was lifted using the safety line and manhandled out onto deck. The second officer commenced administering oxygen, and it was noted that the chief officer was still breathing. At this time, however, a noise was heard from inside the tank, and it was found that the AB had himself fallen and was lying on the same middle platform that the chief officer had been rescued from. An OS and the messman now donned breathing apparatus and entered the tank with a safety line. The AB was retrieved to deck at 0900 hours, but found not to be breathing or to have a pulse. Efforts continued to revive him until an ambulance arrived and took both the chief officer and AB to hospital. The AB was declared dead some hours later, when the life support machine to which he had been connected on arrival was finally switched off. The chief officer partially recovered and was repatriated to the Philippines. It has never been conclusively established whether the chief officer actually climbed into the tank to position the ventilation hose, fell into the tank from deck, or slipped and fell from a position at or near the top of the tank. Given the limited size of the access hatch and the injuries he sustained, the third possibility is considered more likely. The rapid and efficient action of the third officer and the AB undoubtedly saved the life of the chief officer. How the AB came to fall is unknown, but it is believed to be either due to the face mask of the breathing apparatus being knocked off during the removal of the chief officer, or due to him slipping during the same phase of the recovery and being overcome in the nitrogen-rich atmosphere within the tank. May be required to enter a dangerous space. Where entry is expected to occur at sea, the ship should be equipped with the appropriate apparatus. Otherwise, entry should be deferred until the ship has docked, and use can be made of equipment obtained from shore. Personnel assigned to operate the resuscitation equipment in the event of an emergency should receive adequate training in its operation. Once again, the ship's designated safety officer should ensure that any new crew members who will be involved in its operation are familiar with the particular equipment on board. The safety management system should provide for periodic checking and recording of levels in the oxygen cylinders. This 68,000 deadweight tons bulk carrier was loaded with a cargo of petroleum coke, otherwise known as petcoke. The holes of the vessel were accessed down vertical ladders at each end of the compartment. When she arrived in port for discharge, the ship was boarded by a young surveyor who told the chief officer in conversation while they were completing the paperwork that he was on his first job alone, without a senior surveyor supervising his work. He explained that his instructions called for samples from each hold. The hatches were still closed as the vessel came alongside, and the crew commenced opening them, working from forward, but it seemed to be taking longer than usual. The chief officer left the surveyor in the ship's office and went on deck to try and speed up the process. The surveyor decided to start taking his samples and went on deck himself. As there appeared to be a problem with the hatch forward, he decided to start at the aft hold. He released the securing dogs on the starboard side at the aft end of number 8 hold and opened the lid. He then lowered his sampling gear inside the trunk and climbed inside, leaving his notebook and baseball cap on a frame nearby. Some minutes later, the deck cadet, passing down the same side of the deck, spotted the cap and book and paused to investigate. He then spotted the open hatch and looked inside. He could just make out the heel of a boot under the edge of a frame in the beam of his flashlight. The deck cadet ran out to the side of the ship and jumped up and down, waving his arms and shouting, until he gained the attention of a sailor forward, then ran back to the hatch. He then evidently entered the hold himself, in an attempt to reach the man inside. The sailor forward, who had seen the deck cadet, had in the meantime run aft and quickly appraised the situation. Luckily, a second sailor arrived shortly behind him, and this man had a radio and raised the alarm. One man then stayed by the hatch, and the other went to the safety locker on the poop deck to get a self-contained breathing apparatus. The chief officer was next to arrive on scene, followed almost immediately by the third officer. The chief officer put his leg over the coaming of the hatch and made to climb straight down into the hold as well. The third officer reminded him of the likely dangers of the atmosphere inside the hole, but he swung his other leg over onto the top of the ladder as well. The third officer then shouted at the chief officer, and an argument ensued, with the third officer actually grasping the chief officer around the neck and the chief officer striking out at the third officer in return. the two of them by now shouting continuously at each other. At this stage, the master arrived at the hatch and immediately ordered the chief officer to climb back out of the hatch. The deck cadet was seen to be in a sitting position on the surface of the cargo, with his back against the access ladder, but not moving. Rescue equipment and more personnel had now started to arrive, and the third officer and second engineer donned self-contained breathing apparatus and climbed down the ladder. Two of the crew, under direction of the master, opened the hatch. When the rescue team reached the deck cadet, he was seen to have vomited and was semi-conscious, but clearly still alive. The surveyor was either unconscious or dead. Within minutes, the two were lifted back up to the deck. The alarm had also been raised on shore, and a medical team from the installation was soon on board. The surveyor was confirmed as dead at the scene, and the deck cadet was transferred to hospital, where, over the next few days, he made a steady recovery. The surveyor succumbed to the lack of oxygen and presence of fumes in the hold, and the deck cadet almost suffered an identical fate. The clear thinking and determination of the third officer in restraining the chief officer, despite his seniority, undoubtedly prevented a third casualty. This example involves a general cargo vessel with a conventional four-peak tank and collision bulkhead. A sluice gate valve is mounted inside the four-peak tank with a transmission to the forecastle deck. Due to a misalignment in the transmission rods to the deck, this arrangement failed and the coupling broke off, making it impossible to empty the tank in the normal way. It was decided to contract a shoreside firm with suitable equipment at the next port of call, to empty the four-peak tank and carry out the necessary repairs. This happened to be in a tropical area with high humidity. A portable, air-driven, deep well pump was to be lowered into the four-peak tank through the manhole. The pump was to be driven by an air compressor, itself driven by a separate diesel generator located on the quayside adjacent to the forecastle, set up and tended by the contractor. When the tank was partially emptied, the pump had to be relocated lower down in the tank, being manoeuvred past one of the internal stringer plates. One of the fitters entered the tank, believing that fresh air was being drawn in from outside as the tank was deballasted. Shortly after entering the forepeak and descending to the stringer plate, he was seen to sit down, then slump forward, with his back to the bulkhead and adjacent to the ladder. The alarm was raised, and a rescue party assembled. The compressor was stopped and deballasting halted. As the temperature and humidity at the time of the incident were both extremely high, and the fitter was somewhat elderly, the rescue team initially suspected that the man had simply attempted too much. The chief officer therefore entered the tank without a breathing apparatus to assist the fitter. He reached the man and fitted him into a safety harness that had been lowered from above. As the team outside began to pull, he guided the semi-conscious fitter through the manhole. As he exited himself, however, he was conscious of a nauseous sensation and severe headache, such that he too required assistance. Both men were taken to hospital, but returned to the ship later in the day. Subsequent investigation and analysis revealed that both sludge and rust in the forepeak were minimal. However, it was noted that the compressor and generator had been arranged facing each other on a flatbed trailer parked in the lee of the forecastle. There was no wind, and, in effect, the intake of the compressor was directly in line with the exhaust outlet of the diesel generator. With each stroke of the pump inside the forepeak, contaminated air was being added to the atmosphere. No meter readings were taken, either prior to or following the entry, so the theory remains unproven, but is considered to be the most likely cause of the problem. Either way, both men were lucky to escape from what was undoubtedly a hazardous atmosphere.